Hello everyone. So in my previous session, I have explained you all like thread, runnable, and callable thread class, runnable interface, callable interface, how to implement thread, how to with some very basic sample example I have shown you. Today we'll continue from there, and maybe some few other stuffs I will let you know, anonymous class and maybe string builder, string buffer, which I have not told, but I just recalled today. I will explain that also. And synchronize, what is synchronized block and what is synchronized, keyword. I will tell that also. This is how we will end our Java session. If you need any more information, you can always connect me on my mail ID. I will Today I will share my phone number also. You have it. If you are watching my video, then at the end of my video, you'll be able to get my phone number. And this is my mail ID, satya.sahu@gmail.com. And this mail ID I always use for education purpose, education purpose. So you can always mail me on this mail ID. This is my LinkedIn profile. You can always message me on my LinkedIn, or you can connect me on my LinkedIn. And this is my cell number. This cell number I have from long time, that is from 2006 onward, and this cell number is going to be with me till my death. So you can always call me on this cell if you need any information uh, on Java technology or Java related frameworks, or maybe AWS. Just can call me. I'll help you to guide in that technology. Thank you. Note it out. Let's start today's session. Right? So my number you have, this is the same number, 99864883996. This is my number. Keep it. And this is my LinkedIn ID. This is my mail ID. And in that description of the video where I've uploaded on YouTube, the video which I've uploaded on YouTube, in that particular description you will find my GitHub link. In that GitHub link you will find these particular programs or sample programs available there. So let me start today's session. So today's session is I will just explain few concept of Java, right? Few concept of Java. So let's say I'll comment out this callable. Callable you all might have understood by this time how does callable work, or how does this thing work. We have one user callable, right, class, and we have one more. What is that? User callable class. One is user callable and one is user callable class. So two classes we have. You see, there is something called synchronized, right? SYNTH. There is something called synchronized keyword. If you write it in front of the method public synchronized voice object call throws, if you write it in front of the method, right? What it does, it will not execute this callable, or any other thread cannot access this callable or this call method, right? So how I'm going to show you, we will show this, I will show you this by this. Hold on. So here we'll comment out user callable. We have done the changes in user callable class, so we'll only keep user callable class. Okay? Now user callable class will have one callable instance, and we'll create one more callable instance. Now we'll click, if we'll click, we'll more callable, or we can pass that two callable instance to submit, right? We'll pass that callable class twice to the submit, right? And what will happen? You can see here, right? See it, try and run it. See threadman pull one, thread one. Still the program is running. I think some seconds of thread pull one, thread two. Now it's on Madhusmita Sahu plus Madhusmita Sahu, right? So now see, in this callable class, I will pass string. Hold on. in this callable class, I'll create an interface constructor here. I have here private name, string name. I'll create another like this equal to nothing. If you don't pass anything, it will be by default null. And here what I will do, like this, right? So what happened? I will create here. This is how what I will do. I will create here a particular. I will just remove the synchronized one first. I will create here uh, for loop I equal to 0 less than 10. Let's say I just create a for loop only for this. Print, not print only. For sleep also I will create that. Inside this for loop I'll keep this in here. And I have removed the synchronized. First you see how it works without synchronized, then with synchronized, right? So this is how this is, and here it will see employee dot name is dot. Let's go to main, and what we will do here, we will pass Satyananda, and then I will create one more user callable class object where I will put Vishmita. In the below second one, right in line of 45. Now I am not using synchronize. I will just run it. See how it happens. The same program I just modified a little bit. Add a constructor. Yesterday's previous sessions program I just add a constructor. So if you see thread, first main thread, then pull one, thread two, it went to thread two, then thread one, then thread one, then thread two. So basically, if you see thread one, thread two, thread one, thread two, in that for loop, it is executing thread one, thread two, thread one, thread two, right? So in that for loop, whenever the for loop will get end, if you go to the callable, whenever this go to the callable, whenever this this thread whenever this will get end, right, this for loop will get end, then it will set this name, and then it will give us the output, right? And if you see thread 1, thread 2, thread 1, thread 2, alternatively they're executing it, right? Alternately they're executing it. Basically, whenever whoever is getting access, they're executing that. At the end, it printed Satyananda Sahu plus then Smith. So see if I use synchronize, I've used synchronized keyword here in front of the method at the method level. Now I run the same program. Thread 1 started, thread 2 started, right? Thread 1, thread 2, thread 1, thread 2. This is how it is going to execute. There is no difference. You will not be able to see the difference. Right? But when basically you are going to have a producer consumer program, or using a runnable, you are trying to implement some blocking queue kind of concept, you use the synchronize. Until unless the object won't release that key of that particular thing, it's not going to allow it to execute. Now this synchronize can be, you know, used here in a block. See what changes I'm doing like this. And what I will do, I will say this. basically get the local lock of the subject. So this, see what is the difference here? We'll get it. Concurrent Java long dot error unusual compilation problem. Where is the compilation issue? Somewhere we did something wrong. We need to call level. Okay. Hmm. Okay. So basically, this employee is not visible, right? So let me take this create this employee outside the synchronous block. So it will be visible. So this is visible. And if all the other we can do, we can have everything inside the synchronized block. Everything we can have inside the synchronized block. That also can be done, I think. So let's see. The whole function is inside the synchronized block of this object. So now let's run it and what is the difference? See, this is how you practice. You go through the theory concept and then you understand what exactly how it executes. Thread has more in-depth concept. If you really want to learn, just message me. I will tell you. I will learn. See, here you don't see much of the this thing, the differences between while using synchronize, right? So the same thing what we will do, the same thing we will do with the thread. Now I have with the runnable interface, see or runnable implementation. This is how we go with this synchronized concept. At the end, I will tell what actually synchronized does. Yes, this is synchronized. What it actually does, it basically this whenever you use this keyword, this keyword for whenever you use this keyword, it exactly take the lock of that object, and any other thread is accessing that particular process or method, it won't allow until unless it has finished the operation in that particular thread. Once it has done the operation in that particular thread, then it will release the lock, and the other objects or thread will be able to access that particular block, piece of code, or the method, whatever you have made synchronized. Right? So let's go to the user enable now. When user enable, see this is there. So what I will do, I'll make this synchronized. Before making synchronization, see the output. I thought of writing a producer consumer program, but it is the same thing. You just go to the internet, Google it, you will find lots of program on synchronize, and they will show you how it works synchronously. I have one producer consumer program here, which previously I have done. I'll show you that. See, this is how it was running, right? So if I add the synchronized keyword here, synchronized keyword here, what it will happen? We'll comment only one class, user unknown class. We'll only have one class, right? And that what you will do, that same we will create let's say user enable class. So here user enable only, right? And then we'll run it. See, this is how it works. It's doesn't show you any difference here, but I'll show you one program I have already done earlier. I just do a bit of explanation there. When you have anything called, let me go to that program here. This is, I think, hmm, this is what I have done here, synchronized, right? So this method, if you see, so if you see here, this method, if I run it, right? This is I've done synchronized not with if you see thread sleep synchronized. Here this is a thread sleep, and this class is not basically a thread class. I've used synchronized public void sleep to make this class synchronized. And if I run this method, it is going to make it synchronized. See, it is hello synchronized dual. First one you see what is how the output is. You see the second one and third one, right? And I'll make it like this. You can see it. See non-synchronized example. Hello world synchronized. Here there is no synchronized used and how the example. You can find this all code in Git. Just to go and check it. See this is a thread sleep class. Here I am using sleep and this class is not used any synchronized. You know any synchronized in this particular method. What I'm doing, I'm just here the end bucket, here the start bucket, here the message. And what again I have done in this inside this, if you see thread slip, new thread slip, and what I'm doing color thread A, new color thread slip, right? Then B, new color thread slip synchronize. Then C, new color thread synchronize. Then I'm doing A dot thread dot start B dot thread dot start C dot thread dot start. I'm starting the thread here, right? And then I'm trying to join a dot thread dot join a b dot thread dot join c dot thread dot join. Right? So if you see what happened here in the first output, since there is no synchronized hello world synchronized, it came in a haphazard way. The second one is using synchronized example with synchronized keyword. That is this one, synchronized example thread synchronized sleep. If you go to this class, here it is the keyword used in front of the method. The next one is synchronized example with synchronized block. The next one is synchronized example with synchronized block. If you go down, you will see here color thread synchronized. Here, if you come to this run method, I have written a block this dot thread sleep. I'm holding on thread sleep basically on this sleep interface. The thread sleep object. I'm holding the lock of that object. Whoever calls this thread, they will hold the lock of that object until unless they are not able to that not able to release that particular method, then no one can access it, right? Similarly, here what you can do in user callable, we are making here what is that object call throws exception, right? Object call throws exception. Here, not this one, I think. Yeah, this one. Here I'm doing thread dot sleep, right? 5,000 and synchronized on this. So here what we can do, we can always we can always hold the object of some other parameter like private, right? Equal to thread equal to dot current thread, right? It will give me the current thread object. And what I can do, I can copy this and I can use instead of this thread here, current thread, right? So this is how you can always, inside a block like line number 18, whatever I'm explaining, inside a block, always you can add this thread. It depends on you. Logically, you have to think what on which you are going to apply the law. Then only your program will work properly. If you want to learn more about thread, you can want a threading in Java. You can always connect me. I have said already said in the beginning of this session my mail ID, my LinkedIn account, my what is that LinkedIn account, my phone number. I will put my YouTube, my channel. This is my channel, right? This is my YouTube channel for Java. to. Well, I'll put my GitHub link also for you all. If I'm trying to put, let me put everything here. Right. This is my GitHub link, right? For beginners in Java, those who are beginners in Java, they can learn from here. So let me put that here also. See, this is my GitHub link. You can always download this code from there, and based on that, you can always, get into the things. So this is how synchronized block and synchronized this thing work. So the basic concept of here, the basic concept here is if you say line number 18, I have written synchronized thread. So the lock of thread is locked now. No, that thread object is locked now. Anyone who want to access that thread, they will not be able to access that thread. They until unless the thread was accessed it first, that thread will basically the thread object which has accessed it first, that thread will uh, hold the lock. It will execute the business logic inside that. Once it has done or executed the business logic, then it will release the lock, and someone else then only can access that particular lock of that particular object. So this is how called thread. This is how called synchronized, synchronized keyword and synchronized block. This is how it works. So remember, on screen I'm sharing again and again. These are my contact details. If you want anything more knowledge or more information about the concept theories, you can always call me. You can always connect me. This is how it is, right? So this is how thread, right? This is how thread works. Thread is a big chapter. If I start explaining, it will continue. So I want to, I have to full stop somewhere. So I did a full stop here about thread. There is something called blocking queue, producer, consumer. If you want to learn all this, you can always connect me. I will help you out, or I will, help you in learning all these concepts. So here, the same thing user callable I use thread. So if I run it, you will see the same output. If you synchronize output, I can show you if you want. We if you want, I can show you. I will take a special session for you all, and I can show you that. Just message me. Just message me. See now what happened. Thread main pull one thread two, pull one thread two. Why it is going to only thread two? User callable class, user callable class. Why it is going only thread 2, why it is not coming to thread 1. Earlier you have seen it is alternately, showing thread 1, thread 1, thread 1. Now it is only showing thread 2, thread 2, thread 2, thread 2, thread 2. Why? The reason that I used it on the thread object, current thread. And whoever the thread, whoever accessed it first, that is the current thread. So until unless current thread won't finish the work, the first thread will wait to access it. Right? So since we have taken the root for 10 times, you know, so it will iterate in every 5 second 10 time, and then see after that thread one it printed, right? After that it printed thread one. So this is how synchronized works. See, I can explain you more about it's a time, right? We need time to explain, and this is how synchronized work here. This is how synchronized work. Now if you see, I will remove this synchronized, if I make it again this, it will access alternatively. You can observe that. Before, see how it happened. Again, same Satyananda Sahu plus Madhukar Sahu. Anywhere go. Satyananda Sahu plus Madhusudana Sahu. Now I will make it this, and I'll explain you why it is not working with this, why it is working with thread. Then we will end thread. Operating system might have read blocking queue. So blocking queue also comes under this kind of concept. So if you want to learn all these things, in this thing are available on Java, and if these are also available on the internet very well like explained, you can go there and read. Or if you want to learn from me, you can always message me, and you have all of my information in front of you, right? See, again it started printing alternate 2 1 2 1 1 2 1 2 like that, right? See what happens when we're synchronizing on this object. What happens, we are synchronizing on this user callable class, right? And callable class is class has this method, but it is not blocking that, it is not taking the log of that. But when I use thread, right, so I'm calling from a thread, that thread, current thread, right? So what happened whenever the current thread, that is the fast thread, it's going to lock the object, right? This thread is going to lock the object. When it is going to lock this object, now someone else, this particular piece of code, this particular piece of code was accessed or locked by this thread object. So no one else can access it now, right? No one else cannot access it now until unless the current thread he finish this particular block piece of code. And once the current thread finishes the particular block of code, then the other thread will be able to access. So I'll reduce the time a little bit to 100, 1,000 to run this program faster, right? So let me run it again. You can see. See now thread one. That time thread two and now thread one has came into picture, right? See, until unless thread one won't finish, thread two will not come. If I put this, what is happening? Alternative happening. It was not working, right? Now thread two. So this is kind of sequence. Okay, at the end it will come. See how it works. That is called thread locking system or synchronized work. So now we are done with thread. I will go and explain about string buffer, string builder, which I missed previously. So let me go to that particular. Do we have example string? I get here. I have explained, right? Okay. So inside this will create another class string main. The main method, right? So earlier you have understood what is string. So how to create a string object. String is equal to string. That way I can do. I can also, you know, I can also just use string letter, right? This is how you create string object. We'll go for string buffer. This is our string buffer. We create a string buffer object like this, and then we can do. If let's say same, if you want to create Satya, you can write Satya inside this, right? So there, how we are doing? We are doing concatenate, right? And we are assigning to a literal variable s dot concatenate. Then we'll assign it to another variable. Otherwise, you will lose that. Here, what you can do is b dot append. And then you just append and certain, you know, then comma, then sb dot append. Again, you can do append. You can do double quote. You can have space sh, right? Then again do sb dot append. sb dot append. Then you do s plus, right? Then sb dot happened. And it's already space have given, so let's write null, right? Then sp dot append. See that, right? Then sp dot. Now if I print it, see what you are getting. Satyananda plus Madhusmita. It got appended. But in case of string concatenate, see if I do s dot concat, right? And here in concat, what I will do, let's say I'll put double quote s plus Madhu, and I will try to print it here just before, you know, string buffer. So what it will print? It will print only Satya. See, only Satya. Even you have done concatenate, but it is only printing Satya. What you have to do? Again, s equal to like this. You do, then you see what is the output. Satya plus Madhu, Satyananda plus Madhu, right? So there is nothing much difference between string buffer and string builder. String, what set of operation you have for string buffer, the similar set of operation you have for string builder. What is the difference? You will see it. I will show it to you. And before that, I will go for one more concept here that is called anonymous class, right? So see, let me create one interface here and data type simple interface, small interface. I create an interface, let's say ABC. I'll just have a method here doing something, right? This is the employee, this is the method. Now, interface need, if you want to create an, if you want to create, if you want to create an object of an interface, then we need to have a class, right? We need to have a class. That class which is implementing that interface, and then only will be able to create that. Now, what I will do, ABC, 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 equal to new. This is called anonymous class because this class, sorry, this is called inline class. This is inline class where you're creating the object up front of that particular class, right? This is called inline class, not anonymous. Anonymous class will not have a name, it has a name, right? So we will go for that, and here what I will do, I will implement SYSO something. Okay. And let's say I will return something also. Anonymous class, right? You will return 0, let's say, and we'll make this as a right. We'll call here. We created an instance of this, and then we'll call here abc dot method. We'll print it here. Fine. So now let's go. Let's change here. It is written word. That's why it is showing error. So let it make it int. Right? By default, the method declaration of an interface is public abstract. So you need to record to define public or abstract. that can be understood by the compiler. So see, this error is gone. Now if I run it, what you can see, it is printing Satya, it is printing 0. Now if I comment out this, yeah, now if I comment out calling of this method, it will not print Satya or it will print Satya. What you guys are guessing. See the outcome, it is not printing Satya. Basically the method declaration is here, and this method or this class, this anonymous class or this inline class implementation, it is only for here. And this class implementation is only available inside this main method, not outside this main method. So let's go to Google. We'll go slowly. I will put here difference runnable, callable. We'll start from here, right? Thread, runnable, and callable. See thread and runnable, there is not much difference. So most of the things they are showing here only runnable and callable, features. If you see here, it is interface, public interface runnable, void run, public interface callable, it has a method called call, it has a method called run. And in callable it returns, in runnable it is void, no return type. Right? That's what it is explaining. Checked exception cannot throw checked exception, but can throw checked exception in case of callable. Introduced in Java 1.5, that is runnable. And callable came into existence in Java 5 or 1.5, that is in concurrent packages, right? Simplicity, simple and lightweight, more powerful and flexible. Runnable is simple and lightweight, callable is more powerful and flexible. You can do lots of tasks. Using context, uses context. Runnable, simple task, background task, event handling. But callable, complex competition, task needing results, error handling, many other stuff we can do using callable. Thread creation can be directly associated with thread, often used with executor service. So callable you cannot directly associate with thread, but you can use it with executor service. Internally, executor service creates thread for callable. That's how it is, right? So no result returned, result is written in case of runnable and callable. So next we'll go for the difference between string, string buffer and string builder. So this is yeah. So let's go down. This is the place. This is what I was looking for. Sometime we will access internet. This kind of things will come. Uh, so okay, see now string builder, string buffer, immutability. If you talk about immutability feature, string is immutable. Once created, cannot be changed. String builder, mutable. Content can be changed. String buffer, mutable. Content can be changed. Thread substitute, string thread substitute due to immutable. It is thread substitute due to immutable because you cannot change it. String builder, not thread substitute, ideal for single threaded scenarios. If you talk about string buffer, thread safe, synchronized for multi-thread scenario. String buffer is always thread safe. Performance, efficient for constant values. String is always efficient for constant values. In case faster for frequent changes in single-threaded environment. It is faster for frequent changes in single-threaded environment. Slower due to synchronization, but necessary in multi-threaded. If you are using multi-thread, you have to use string buffer, but it's a little slower. That's fine. User scenario, constant keys in collections. Building complex strings, frequent modification, building complex strings, frequent modification. Concatenation else can use plus operator. You can always use, in string, you can use concat, you can also use plus operator. That operator is overloaded. It can do integer number addition along with that it can conjoin two strings or multiple strings, right? Class operator can be used in case of string, but in case of string builder and string buffer, you have to use append method for adding or complete. Memory efficiency. Memory efficient with string full. String to string always use string full for memory, whereas you know string builder and string buffer they don't use. So more memory efficient than string for frequent changes, similar to string builder, but synchronized might add overhead. See, in case of string buffer and string builder, they use heap memory, and they're not using string full. Only string will use string full. So I've shown you one example here with string buffer. That same example goes for string builder also. All the set of APIs or operations or the methods available on string buffer, the same methods are available in string builder. They are together sync, right? So you can always use if you are using a thread. If you are worried about thread synchronization concept, if you are worried about multi-thread application, then go for string buffer. If it is not multi-thread application, just go for string builder, and you can use it, right? So next is anonymous class, right? And inner class. Uh, Anonymous class and inner class in Java. See, first this fellow has given a beautiful. He has given a say class outer inside that if you define for it is called inner class. Class outer static inner class. Class outer object new. This is anonymous class, right? What I have done that is anonymous class. I was just a bit confused. What I have done that is anonymous class. So here another, if you see public static void new file. This is basically anonymous class. You know this class is anonymous class. This is inner class and this is anonymous inner class. See, there's so many concept of class, inner class, nested class. You can all go through that. I have shown you one example of anonymous class. This is, and if you want to have one inner class here, always you can have this inner class test. You can always have class test, and then you start here, right? Let's say method. No, I'm showing one inner class. This is anonymous inner class, you can say, or anonymous class. This is totally inner class because this is inside one main ST class is this class, test class, right? So test inside this, I'll go and create a method. Let's say public void method, create a method, right? And in this, I'll just have a sys method, right? And what I will do, I'll try to print that here also. Since it is the inner class, it is visible here, inside this class. Here, like this, the same way how you create test dot, then method, right? So this is how you do what it is saying. No enclosing instance of type MNST is accessible must qualify the allocation with enclosing instance of type MNST x new a, where x is an instance of. Okay, so here what we'll have, here we need to have like this. I think here we need to have main st dot, right? We need to have like this to st, and then use this main st to create an object of this class. I think so. Something else. Hmm. Hold on. Let's see what it is saying. No enclosing instance of type managed is accessible. Must qualify the allocation with an enclosing instance of type managed. Example x dot new a, where x is instance of managed. Okay, so basically they are saying you should have managed dot new like this. You know, this is the approach you should take to create an instance of inner class. See, always you will get if you use Eclipse or some kind of editor, always you will get the help how to do it. Sometimes even if you miss it out, you will be able to do it. See, it is printing Madhu, right? So here I will show you by changing something here. See, this is how it is printing, right? Yeah, I'm trying to put a message. I'm trying to put a message here. Satya and Madhu will celebrate their anniversary. Satya, my full name also I'll put because there are so many Satyas, right? There are so many Satyas. So people might get confused. So let's put the full name also. Right? So this is the message I'm going to print. Satyanand Sahu, Madhusmita Sahu will celebrate their marriage anniversary on 18th May. This is how it is. Right? This is how it is. This is our inner class and anonymous class. So let's see the difference when you are if it is written difference. Yeah, here. No, this is lambda. Okay, yeah, we thought of explaining that anonymous class versus lambda. What is the difference, right? So since I told you anonymous class and I have taught you, this lambda expression, let's go and see the difference here. Yeah, now it is visible to you all completely, right? Anonymous inner class and lambda expression. What is the difference? It is a class without name. Lambda expression. It is see when I defined that interface, does I have given any class name there? If you see when I'm creating a class here ABC, is there do I have any class name here? No, it is taking the class name of interface. If you try to print the two string of this particular ABC, what it will give you? See it. That's a good thing, to so just ABC dot two string. And same I will print for this test object also. See what you're getting. See com dot example dot data dot manage t at the rate some it has given, right? And for test, com dot example dot data type. Package structure is there, main st class is there. After that, a dollar symbol. After that, the dollar symbol used and then the inner class name. Dollar symbol and then the inner class name and then at the rate hash code. So in case of anonymous class also, it has done the same thing. Main st, the class name, then dollar symbol, then one. That is it has taken the numeric value for anonymous class one at the rate this. Right? So this is how you can see two string also. Let's go and finish that difference. So anonymous inner class, it is a class without name. Lambda, it is a method without name. Right? Lambda is basically a kind of function. That's how we call functional interface and we implement the functions. It's a method without name. Anonymous inner class, it can extend abstract and concrete class, right? Anonymous anonymous inner class can extend abstract and concrete class. What is lambda expression? It can not extend abstract and concrete class. So see, if you read all this, and if you're really interested in Java, there is lots of concept in Java to learn, and you can implement. It's huge. So it can implement an interface. Next point, it can implement an interface that contains any number of abstract methods. And in the class, it can implement, you know, an interface that has n number of abstract methods. But in case of lambda expression, single abstract method. That is our lambda expression. You have a functional interface. Which is, what is a functional interface? A functional interface is basically an interface which will have only a single method inside it. So you have to implement single abstract methods. Coming to the next, inside this we can declare instance variable. In universe class, we can also declare instance variable. It doesn't allow, in case of lambda expression, it doesn't allow to declaration of instance variable, whether the variables declared simply act as local variable, right? In anonymous nucleus can be instantiated. Lambda expression cannot be instantiated. That's how it is, just a method. Whatever you write inside that, it get executed that method in the sequence, right? So inside anonymous inner class, this always refers to the current anonymous class inner class object, but not the outer object. Inside lambda expression, this always refers to the current outer class object that is enclosing the class object. See this object. If I do inside this inner class, if I refer to this, always it will be for this class. It will not be for the outer class. But in case of lambda, it will be for the outer class. Why? Lambda is not a class. Lambda is a method, a anonymous method. It is the best choice if we want to handle multiple methods. If you want to handle multiple methods, multiple way of implementations for a particular interface during runtime or during execution of the program, then it's the best choice. And for lambda, it is the best choice if you want to handle interface, if you want to handle functional interface, or if you want to have specific set of implementation for a method, then you will have that particular. That is the advantage of using lambda expression. At the time of compilation, a separate dot class file will be generated. In anonymous class, a separate dot class file will be generated. At the time of compilation, no separate dot class file will be generated. It simply convert it into a private method out of class, right? It will create a private method for the class, but in case of this fellow, in case of anonymous class, you will have a different dot class file. We will see that if possible. I will show you that also. Memory allocation is on demand whenever we are creating an object. Memory allocation is on demand based on the memory that object needed, that will be allocated on heap. But it always resides on in a permanent memory of JVM. It's a method, right? Lambda is a method, that's why it's always resides in it. That's how it is, right? In a JVM. So let me show you this particular dot class file. If I'm able to see where this guy is, producing and keeping the classes, my bin folder. Let's see if I can find that part. The bin folder. See, if you go to com, example, data type, right? See, $1 class, MNST $1, MNST $1 class, that is the anonymous class, right? And MN$ST, that is the inner class. These are the classes you can see, and MNST is the actual class, right? If I go to the lambda, wherever we have implemented lambda, yeah. See, all these interfaces and classes are there. You will have the main class, but you will lambda example X. This is the class which we have implemented or created anonymous method or lambdas. Do we have that lambda classes here? No. If you remember, if you have seen my previous examples, you will not be able to find any lambda classes or lambda expressions class get created, because they are inside this. And let's say I will decompile this class, right? I am going to decompile this class. Let's see if this decompilation can happen in Eclipse itself. If I put it here, if Eclipse is able to, if Eclipse is able to, you know, if Eclipse is able to, 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 if Eclipse is able No, it is not showing me. It is not showing me. Dot plus file, it is not showing me. Otherwise, I can, let me see if I drag and drop that file into the Eclipse editor. Is it? It is. Yes. The public static void main. See, it is what it is showing. It is showing the code in a format. No, there are so many decompilers. So we will download one decompiler and we'll see. JD Java decompiler. There is some JD Java decompiler. That is what I used to, verify when I was working with different source code which don't belongs to me or don't belong to our organization, and we don't have any, we don't have any other source to or documentation to read and see what they have written, how the program is working. We used to decompile the code, and I used to decompile the code. I used to go through the code what they have written, and then I used to identify what is there, what is not there. This is all nowadays. I think people will not be doing because every organization or vendor they are sharing their APIs. They have documentation available. Collection also I told you I'll show you the collection thing, generic thing. That also I will show you. Since I downloaded this decompiler, I'll show that also. See, one lambda class. This lambda class will take it and we'll put it here. What happened? This dot file place. No files to open, or it is taking some time. Hmm. Lambda example, right? This one. What happened? Why it is not opening? Not opening, yeah. Some other class, let me try. Open listen file, menu file, listen file, drag and drop from the Explorer. Why it is not working? Is there some issue with this decompiler? It's pathetic. I have downloaded some jar. Let's see if that jars are. Sometime back I downloaded some jar here. That if that jars are, where is gone that jar? Yeah, it is opening the jar file. Yeah, why it is not opening the class? Okay, what we will do, we will export this project as a jar, and then we will see, right? That is the last part I am going to do today, and then we'll end the session. And Java is done. If you are interested to learn something more in Java, kindly, let me know. Let's go to the bin folder. I have done some kind of group up. I pasted, you know, source, the one dot plus file. Let me delete these, and one more dot plus file. I pasted it inside the data type. Yeah, delete this. Right? And remove all the error from the project to build a jar. I'll show you to see how we can build a jar here. This came here. Why? Yes. So this error is gone. One more error is there in the exception and the error. What is that error? Let's see. File not found exception. Why? No import or what? Something like that. Or let me remove this. No, what is it? Right. So that error is also gone. So see, to build a jar, you have to remove all the error inside your project. So all error is gone now. The project is errorless. Let's go and export is there, right? And click on export, and there will be jar file, Java jar, right? And next, create my project. Select my project. Now only we want to create a my project. So select my project. Export generated.class file and resources. That's how. Then you have to give the jar name. Test dot jar. Let's say next finish. Jar export finished. Oh, the location now. Let's see. The location should be there somewhere in that same project or somewhere where it has export. Oh, again, what to do? I think I have not seen the path. Fine, I will do it again. I missed. Or if I see the path again, where it is gone. Where it is gone, let's see the browse and see where it is taking to us. Java session. Okay, it's inside the Java session. Fine, no need of generating again. Go back to the Java session. So here it is. It is taking to the default Eclipse workspace, right? Eclipse workspace location. This. Now get this decompiler, drag this jar and put it here. See, you got everything, right? Now inside this counted example, we'll go fast and see that inner class we have created inside data type, right? See, this is the main class and this is the main ST. So main ST class you will see. See in main ST class, you have class test here, right? Method and this ABC anonymous class here, right? So what is this main ST1 class? See it, class null implements ABC. What is this? Class test implement this. The same thing what I have written, right? In class test, it's just showing it is an inner class because it has a name, but it is an inner class, right? So it is showing Satyananda Sahu and Smita Sahu will celebrate their marriage anniversary on 18th May, right? Here, if you go msst1.class, it is saying class null because it is anonymous class. It has an interface ABC, but doesn't have any name, right? But the things are same here, right? So now let's go to the generic, which is the class we have used generic collection. Which is the class we have used generic collection.
Good morning, Satya. From geeks4geeks.org. Java
Alexa,
collections class is used
Alexa,
with a static method.
stop. Okay. So see, Alexa, Amazon Alexa, she is also learning Java from me, and she is also learning how to fetch my request efficiently. I want to find that main array list.
From about Amazon.
Alexa, stop. I don't know why no one is calling that fellow. Why she is started talking.
Sorry, I'm having trouble understanding right now.
Yeah,
Please try.
yeah. I am just trying to off you. You stay like that. Let me finish this session. Another few minutes. You are disturbing me. See, if I go to main array list, I am using integer here. Main array list, new array list, integer, right? So you see collection, main array list, main array list class. See here. Oh, nowadays they're having it in compile time, right? So what concept I said that is a long time back. Okay, let me see. During our time, no, when I was coding efficiently as a developer, 2008, 9, 10, 11, 12, that time It was it was not showing in decompiler. Generic in Java is for compile time. It is for compile time or runtime. Java generics are compile time, which means that all generic information is erased at runtime. See, here it is saying, as a result, the JVM is not aware of the type of existence. As generic compile time or any time. Instead, generic compile time feature, their information is not present at runtime. See, I don't know how this fellow, this decompiler is able to do that, but all, let's do one more thing. Let's see this compiled code in Eclipse. I will drop that main array list class the way I did for the other one. Initial bean, right? Let's go to bean. Uh-huh. Yeah, main array list class, right? Let me drag and drop it to Eclipse editor. See, main array list class, line number. This is how Eclipse is decompiling public static void main array list class landscape loop invoke java.line to int value of int integer. See, this is it list. Here there is no generic symbol, right? If you see, there is no generic way of doing this, right? There are some compiler which are actually will not show you the generic, but this compiler actually the old version of the compiler, if I find somewhere I have kept it, it will not show the generic piece of code here, how it is showing here. The generic is no more, that is not visible, that is not available during compile time. So how it will show, right? Because dot class file will not have the generic content or generic implementation. So it should the decompiler should not show the generic implementation, right? So that's how it is. Anyway, we are done with our Java thing today. If you are interested, for listening further video, tomorrow I'll come with something different along with Java or maybe something different tomorrow. So you can keep watching my videos. You will learn many things here. You will learn many things here. So let me stop this sharing. I will end the Java session here. You have all my information, right? Okay, let me share again my information to you all. If you need any clarification or you want to have any session, you want to go go in depth in any of the concepts, you can always contact me on this satya.sahu@gmail.com. This is the mail ID which I use for education purpose. The students or any person who want to learn something from me, they can connect me on this particular mail ID. My LinkedIn profile www.linkedin.com/in/Satyanand Sahu. This is my LinkedIn profile. My cell number is this 99864889396. You can always call on my cell. My LinkedIn profile is always is verified profile. It's not a fake profile. It's original profile. It's verified with my government ID. So this is my YouTube channel where I have uploaded Java videos and more technical videos, technology videos are going to get uploaded. Keep watching. The next is the GitHub where these all program what I have shown you, these programs are available there. Keep watching, keep learning, and if you have anything, call me, message me, comment me on YouTube video section. So we'll end our session today here, and maybe tomorrow or next session it will be something uh, other than Java or along with Java. So we'll see. I will see what I can record for next session and publish it on YouTube. So thank you everyone. See you on next session.